Okay, I want to talk about this one that we have up on the board right now. And the equation I have up on the board is x squared plus 5x minus 2 equals 0. And the directions say to solve. Now, what methods do we know how to solve quadratics so far? We know how to marf, or factor. Okay? We know how to do what? Square root. Grouping would just call factoring. So factoring, Autumn said marf, so that it has 3 terms, so we would think marf. And the other one would be to graph it and just kind of, see where the graph crosses the x-axis. Now here's the deal. Can I factor this? Factors of 2 that add up to 5. That doesn't work, does it? So we can't factor it. We can't square root it because there's x squared and there's an x. So really, right now, the only method we have to solve this would be to graph it. Okay, so let's graph it. My calculator's not working. I need you guys to use your calculators. Why don't you type that in for a second? If you don't have a graphic calculator, go grab one.
Thank you.
Okay, now, where does that graph cross the x-axis? At 2 locations, correct. What numbers are those? I wish my calculator worked here. I would pull it up, but. Is it at whole numbers?
No.
It's not at whole numbers. Okay? So it's not at perfect locations. I'll just let you know, if it was at perfect locations, we would be able to factor it. But since we can't factor it, those solutions where it crosses the x-axis are at weird decimals. Now today, we're going to learn how to find those locations of where they cross the x-axis if they're not perfect. Okay? And the process that we're going to learn today is called completing the square. Okay? So here's the deal. If we can factor, we want to factor. Okay? I kind of use this example is like when it comes to be prom time, I think we all know if we're going to go to the prom, who we kind of want to go to the prom with. Okay? I want to go to the prom with factoring. Now, if factoring doesn't work out, I need to have a backup plan. Does that make sense? You need to have a plan B, or if you're in my case, plan C, D, E, F, and so on. But we want to factor if at all possible because factoring is easy. If factoring doesn't work, or square roots doesn't work, now we have a plan, and it's called completing the square. Okay? So here's step 1. Step 1 is we need to get the equation, or write the equation into standard form. Write equation in standard form. Sometimes, maybe most of the time, it'll already be in standard form. And if I go down here and look at example A here, or the first one, is that in standard form? X squared minus 10x plus 7, that is in standard form. Okay, so that's already done for us. Step 2 is to make sure A equals 1. What do I mean when I say A equals 1? The A value, the number that's in front of x squared needs to be 1 in order to complete the square. Okay? It has to be 1. If it's not, well then hopefully we can factor something out or maybe divide. We'll cross that bridge when we get there. But our A value needs to be 1 in order to complete the square. So if I look down at the first example, isn't our A value already 1? Yep. So those first two steps are already accounted for. The second step is to move our C to other side. I'll say to the other side. Okay, first of all, let's stop. Can I factor this? What are factors of 7 that add up to negative 10?
None.
They don't, okay? So we can't factor it. We can't square root it because there's an x squared and an x. So now we're going to complete the square. It's already in standard form. Our a value is already 1. Now we're going to complete the square. Now here's the deal. This c value isn't allowing us to factor. It's not the right number, okay? It's not the correct one. So we're going to move it to the other side by minusing 7 on both sides. So now I have x squared minus 10x. Now watch me when I write this. I'm going to leave a space there. Leave a little space. Because that c value, negative 7 is not good. I should say positive 7 is not a good c value. It's kind of ugly. It doesn't work in this case. So we're going to get rid of it. And we're going to get a brand new c value here in a second. Okay, so going back up to my step 4 is to find new c value. And we find the new c value by this little formula. B over 2 squared. And then I want you to put add to both sides. Okay, here's what we're going to do. We're going to take our b value and we're going to divide it by 2. Or we're going to say, hey, what's half of our b value? And then we're going to square that number. So that's what that means, b over 2 divided by, or excuse me, b over 2 squared. That's what that means. So if I look here, my b value is negative 10, isn't it? So half of negative 10 is negative 5. And then I'm going to square it. I'm actually going to write this out so you see it. Negative 10 over 2 squared. Well, negative 10 over 2, well, that's negative 5. What's negative 5 squared? 25. Again, you don't need to write that out, but I'm just doing it visually, so hopefully you can, that helps you and you can see it. So it's 25. Now here's what we're going to do. I'm going to add 25 as my new c value. Okay, negative 5 squared, positive 25. Now, we learned in 7th grade that, hey, whatever you do to one side of the equation, guess what? You need to do to the other. So if I add 25 to the left, I need to add 25 to the right. So we just did step 4 there, I believe. We're going to find our new c value. b over 2, and we're going to square that value. In this case, it was 25, and we added to both sides. Step 5, we're going to mini-marf. You need to put right as binomial squared. Okay, we're going to mini-marf, and we need to write as a binomial squared. You'll see what I'm talking about here in a second. Okay, now let's mini-marf this thing. I'm actually going to write this in green. So factors of 25 that add up to negative 10. Isn't that negative 5 and negative 5? So I'm going to call this x minus 5, x minus 5, and that equals what? Negative 7 plus 25, is that 18? 18. Okay, now it says write as a binomial squared because we know that something times itself can just be squared. So instead of calling it x minus 5 times x minus 5, we're gonna write it as x minus 5 squared equals 18. It will always work out that way. If you take half of our b value, square it, add it to both sides, and mini-marf this, it'll always work out there that way. Now, I'll show you that in the next problem. This looks something like we just got done doing, isn't it? The last 2 days. Let's solve that. I guess I'll go back up to our process here. Now it says solve by using square roots. It's kind of a lot of work to write all those steps out, but I think that'll help us here moving forward. You've got the whole process laid out in front of you now. We're going to solve this by using square roots. So what do I need to do here? Square root both sides. So I'm going to get x minus 5 equals plus or minus the square root of 18. Then I'm going to add 5 to both sides. And so x is going to equal 5 plus or minus the square root of 18. Can we simplify square root of 18? Yes. What's my largest perfect square, Marcus? That's a factor of 18. 9. So I'm going to break this up into the square root of 9 and the square root of 2. What's the square root of 9? 3. So I don't have room to write all that out, so I'm just going to call this 3 square root of 2. There are two answers there. It's 5 plus whatever that number is, and 5 minus whatever that number is. Those are our two locations. If we were to type them into our calculator, they're going to be ugly, irrational decimals that never end. Okay? So now, do we not only have a method or methods to find rational zeros, we have a method to find irrational or decimal zeros as well. Marcus.
Will you tell us if they're irrational or rational, or will you not?
His question was, will I tell you if they're rational or irrational? Meaning, hey, am I going to tell you maybe which method to use? I won't. I will maybe on a few of them and say, hey, complete the square or factor, but then I might just say, hey, solve this, and you have to decide which method is best. But again, which one do we want to take to the prom? Factoring. We're always going to start there. We're always going to try factoring. Okay, here we go. What's the first step that I need to do? Standard form. It's already in standard form. The next step is to do what? Is my a value 1? Yes. Absolutely. Now I'm going to move 2 to the other side. X squared. And I'll stop you, because can we factor this? What are factors of 2 that add up to 8? That doesn't make sense. It doesn't work. It's not factorable. So now we're going to complete the square. So I'm going to have x squared plus 8x. I'm going to leave some space there, equals negative 2. Now what do I do? New c value. I'm going to do 8 over 2, which is 4. 4 squared is 16. So I'm going to add 16 on both sides. A common mistake is forgetting to add it to the other side. Now, here's a shortcut. What's our next step? We need a mini-marf. Okay? Now, every time we mini-marf, see what I did in the green over there? We can actually skip that step. Because I know it's going to be something like written like that. And it's going to be x, and whatever this number is whatever half of our b value was. So what's half of 8? Positive 4, so it's going to be plus 4 there. If I go back over here, hey, what was half of negative 10? That was negative 5. Negative 5 goes there. Now, you may ask, why is that? It works out that way because we, through this process of b over 2 squared, get that perfect c value, so this happens. It happens, we do this because we know that'll happen.
Will it always be the square root of the c value?
Always be the square. Yes. Yeah. Because we squared it here. Because we squared it. Does that make sense? Yeah. Okay, so now I'm going to solve it by square roots. I'm going to square root both sides. I'm going to get x plus 4 equals plus or minus the square root of 14. I'm going to minus 4 on both sides. And x is going to equal negative 4 plus or minus the square root of 14. Can we simplify the square root of 14? We can't do that. So there's our answer. This is where the graph crosses the x-axis. Those are our zeros. Those are our x-intercepts. Those are our roots. Those are our solutions. Any questions there? Okay. We're just going to do one of these. Let's do this one over here. Actually, let's do this one over here. First of all, is it in standard form?
No. Yes.
The answer is kind of. It's close, but is it equal to 0? No. So what's minus 15 on both sides to get it equal to 0? I'm a step ahead of myself, aren't I? Minus 60 on both sides, so 3x squared plus 12x. This will be minus 15 equals 0. Okay, now my a value is 3. All right? So here's what we need to do. Isn't there a 3 in common with everything in this case? Okay, so we're going to factor out a 3. So if I factor out a 3, I'm going to be left with x squared plus 6x, 4x minus 5. Okay, once we factor out that 3 is kind of done. It's not going to do much. Now, what do we do from here? Move C to the other side. Now, I'm going to stop. Can we factor this?
Nope.
What are factors of negative 5 that add up to 4? Are there any?
Nope.
5 times 1? Yeah.
Isn't it 5 and 1? Positive 5 and negative 1, that should factor. Now, we're going to complete the square because I want to show you, but in this case, we want to factor this. Okay? We can factor. We want to go take factoring to the prom. Bingo, we're done if we can factor it, and it can. Now, just to show you, I'm going to put the answers over here. I believe x should equal, what did we say?
5.
So we would have gotten x plus 5 and x minus 1, right? And then x is going to equal what here? Negative 5 and x is going to equal 1. So I think those should be our answers when we're all done with this thing if we do it correctly. Okay? So we're gonna complete the square. Okay? So I need to add 5 to the other side. And I'm going to actually not write this 3 down anymore. X squared plus 4x. Leave some room and have 5. Now, b over 2, or half of our b value is 2. 2 squared is 4, so I'm going to add 4 there and there. And so then I can factor this, or mini-marf it. And we know that this is always going to be x, and then whatever half of our b value was. So our b value is 4. Half of 4 is positive 2, so it's going to be x plus 2 equals, squared, equals 9. Now what do we do? Square root both sides. Isn't it funny how some people say root and some people say root? I have x plus 2 equals plus or minus square root of 9 is 3. Now I'm going to minus 2 on both sides, so x is going to equal negative 2 plus or minus 3. Now, what's negative 2 minus 3? Negative 2 minus 3, that's negative 5. And what's negative 2 plus 3? 1. So those are the answers we said we were going to have up here because we noticed that we were able to factor the thing. Now, we had the answers here by doing that much work or completing the square doing that much work. Would you guys agree that factoring is probably our best bet there? So if we can factor it, factor it. Okay, I've got 7 minutes here. I've got 2 problems left. Another thing that we can do is take something that's in standard form, okay, and rewrite it into vertex form. Okay, now here's what we're going to do. I've got my equation, y equals x squared minus 12x plus 18. Okay, and we're basically going to complete the square. Now, when I complete the square, I need to get rid of my c value, don't I? Don't I?
Yeah.
So I'm going to move it to both sides, or move it to the other side. I'm going to have y minus 18 equals x squared minus 12x. And now, to complete the square, we're going to take half of our b value, which is negative 6, square it, which is 36, and I'm going to add 36 onto both sides. Now, when we complete the square, I can now factor this. So when I factor this, this will become x what squared? Minus 6. It's going to be half of our b value. And then over here I'm going to have x plus 18, right? Negative 18 and plus 36 is positive 18. And now lastly, we are going to move 18 over. So I have y equals x minus 6 squared minus 18. So it's kind of like completing the square. It's a little bit different, but wouldn't you guys agree now that that is in vertex form? What's the vertex? 6, negative 18 is the vertex. Okay?
Sorry for the interruption. When the bell rings at 1 o'clock,
Last one here. It says the area of the rectangle is 100 square feet. Find the value of x. Okay? How do I find the area of a rectangle? Length times width, base times height. So I'm going to take my length times width, so I'm going to take x times x plus 10 and set that equal to my area, which is 100. I'm going to distribute that and get x squared plus 10x. And I'm going to move 100 to the other side, so minus 100. So now I have a quadratic and it's set equal to 0. Now let's solve that thing. Those values of x will give me what x represents here in this picture. Now, can I factor that? Factors of 100 that add up to 10. Negative 100 that add up to 10. I don't think that works, does it? No. So here's where we're going to complete the square. I already have an a value there of 1. That's equal to 0, so I'm going to add 100 to both sides. I'm going to get x squared plus 10x, leave a little bit of space, equals 100. We're going to take half of 10, which is 5, square it, which is 25, and I'm going to add that to both sides. Now this becomes x blank squared. What is that? Isn't that going to be plus 5? Plus 5 because it's half of 10. And this is going to equal 125. And now we're going to solve or square root both sides. So when I square root both sides, I'm going to have x plus 5 equals the square root of 125. And then lastly, I need to minus 5 over, and I've already forgot my plus or minus, right? So x is going to equal negative 5 plus or minus the square root of 125. Now, we have two answers. I have negative 5 minus whatever this number is. Hold on. We have minus that number. If I do that, negative 5 minus a number, am I going to get a positive or a negative number? everyone needs to take your calculator. I want you to take negative 5 minus the square root of 125. Negative 5 minus the square root of 125. Niall, what'd you get?
Negative 16.1803.
I'm going to stop there. It keeps going on forever. Okay? Now, negative 5 plus the square root of 125. What do we get there?
6.18.
6.18. Now, can x be negative over here?
No.
X cannot be negative. So therefore, we can omit that one, and there's our answer.